kernel functions can take various forms, right. I mentioned to you that there are two important properties, one is a symmetric property, the other is normalization. So, sometimes they can be having 0 mean, they are centered around 0, right. This is typically what we expect and they are real functions. So, what are good kernel functions? I can have a triangle that is centered at the origin, I can have a cosine like a raised cosine that is centered around the origin, I can have a bell shape, right, Gaussian kernel, etc. So, it can have various forms. So, let us take one such form here. K of x is given by this quantity 1 upon root of 2 pi power m naught exponential of this term, and this is our Gaussian kernel with sigma square equal to 1. But if we bring in a spread parameter sigma, then we can compute this quantity kernel of x minus xi upon h in this manner. We are just bringing this sigma square term, and this is like the Gaussian function that we are familiar with, right. So, for every data point xi you have a kernel which is defined in this manner. Now, with h equals 1, following the Nadaraya-Watson regression estimation, we can arrive at the regression function as a function of x given by this quantity, right. This is the final form. So, all I need is this exponential of these terms and then the observations or observables y sub xi. So, given yi and xi, I can compute the weighted sum in the numerator. This is a weighted sum of these basis functions upon the basis functions that are evaluated at points xi, right. So, given these two quantities, I can compute the regression function as a function of x, and that is what we have. So, the radial basis function has a role here towards regression estimation. So, in the very second module when we talked about linear and logistic regression, we studied some regression models there, right. Now, after we come here deep down after the MLP, we discussed RBFs, and in our discussion of RBFs we discussed how the radial basis functions can be computed, right, and how they form the basis for the learning problem, right. And now another application of these radial basis functions would be in the regression problem, feeding back again to where we started off with. Okay. So, this completes our discussion on radial basis functions. So, you should appreciate there are two applications with RBFs. One is solving this regression problem. The major application would be basically in a learning network. Okay. So, we will get on to the regularization theory post this, look into SVMs and some of these topics and towards the rest of the course.